So today we're talking about the Horner-Wadsworth-Emmons reaction. And in this reaction we're going to take a phosphonate and then form a phosphonate carbanion upon the addition of a strong base. And then it's going to react with this aldehyde here. This doesn't have to be an aldehyde, this could be an alkyl chain, so this could be a ketone. But basically we're going to form our phosphonate carbanion. It's going to attack the aldehyde, and then through a rearrangement we are going to form this alkene. And this reaction is very similar in nature to a commonly known reaction called the Wittig reaction, which you may have seen, in the sense that it's forming an alkene in the same sort of rearrangement. But the difference is that in the Horner-Wadsworth-Emmons reaction, we're using a phosphonate, which turns into a phosphonate carbanion, as opposed to the Wittig, where this substrate is a phosphonium ylide. This reaction actually has a couple advantages over the Wittig, and we'll get to them in a sec, but now let's take a look at the mechanism. So right here, we've got the base deprotonating this carbon, alpha to the phosphorus. So this right here is called our phosphonate carbanion, which allows us to attack the aldehyde, and then we're going to stabilize the charge on the oxygen here, and then this oxygen is going to be allowed to attack the phosphorus, stabilize the charge here. And then we've got this four-membered ring here. This is very similar to what you're going to get in the Wittig reaction, and this is the same sort of detaching of this bond right here and that bond right there. So then the end goal right here, we're going to form this alkene. And I said this reaction has advantages over the Wittig. This is what's going to be left over, and this is a very polar molecule, so it's very water soluble. So in aqueous extractions, this will come out right in your water layer. That will be in your organic layer. So now we'll go to a predicted product question. If you've been paying attention, we've got this. Like I said before, this can be a ketone. Going to react with our phosphonate carbanion through the addition of a strong base. If you want to take a second, and the product you get is right there. And finally, take a look at a total synthesis. So right here we basically got what's called a two-directional Horner-Wadsworth-Emmons. So the reaction is being completed twice, and that will form these two double bonds here, which are then saturated, and then we'll form this molecule here. Thank you for watching.